In this video, I'm going to teach you a little trick with regard to factorials. Namely, when you describe factorials, you describe them using the factors that are involved in the factorial. Okay, and of course, what a factorial is all about is having more than one independent variable. Now, in chapters 10 and 11, both those chapters deal with really just working with one factor. But when we move into 12, which is really the main thing we want to get to in this course, you're going to be dealing with more than one factor. So chapter 10 deals with between subjects factors, which means that you have different sets of participants in each level of a factor. And then within subjects factors are covered in chapter 11, in which case it's the same set of participants that are in each level of the factors. Okay, so I wanted to give you an idea of what I'm talking about here before we get started. So this is really kind of the simplest factorial you can have. It's a 2 by 2 where you have an independent variable 1, or you can think of it as factor. Okay, let's just say we did some experiment on, I don't know, influence of alcohol or something like this. So we had level 1, which was a control condition, no alcohol. Level 2 was a alcohol condition, like 3 drinks worth of alcohol or something like this, right? So the IV is labeled something like alcohol, right? But it has 2 levels, like a control condition, no alcohol, and the 3 drink condition. IV2, now keep in mind, it could be just a factor, a quasi-independent variable. Let's just say that we are looking at sex differences. So this represented sex. So level 1 might be male, level 2 might be female. And so we have 2 levels of that factor. To represent this, right, we'd represent this with calling this a 2 by 2 between subjects factorial if, right, we had different participants in each level of this experiment. Okay, so I'm going to move down to the type of problems that I'm going to give you in this section. So here's one. So in a 2 by 2 between subjects factorial, right, what I want you to be able to answer are the questions that follow. Okay, so when you see this, a 2 by 2, keep in mind each number represents the number of levels of one factor, right? So this one has 2 factors, right? Because we have a 2 by 2. You can think of it as A times B, right? Factor A and factor B. Each one has 2 levels. So this could be something like male, female, and this could be like a control versus 3 drinks of alcohol or something like that. But 2 levels of that factor. So if you're following me, then the answer to the first question here is how many factors are there? Well, this could be rewritten as going factor A times factor B. And so the number of factors here would be 2, right? We have an alcohol factor and a sex as a factor, if that's what we did in this, if that's the experiment we're talking about. Okay. Then in one of the videos for one of your assignments, we talked about main effects and interactions. Okay, main effects are the overall effect of one factor, right? So you can imagine if we have 2 factors here, how many main effects are possible? These answers are going to be identical. Okay, so the answer is 2. You have a possible main effect of alcohol, and you have a possible main effect of sex, if those, once again, if those are the names that we give our factors. And this is as simple as that. So the answers for how many factors, how many main effects should always be the same. Okay, the next question is how many cells or conditions are there? And if I just bring it back to that design, you can kind of see the cells right there. So you know the answer is 4 when you look at it in this fashion. But to get this number 4, right, it was just, I took this 2 levels here and 2 levels there, multiplied them by each other. Don't add them, but multiply them, and you'll get 4. Okay, so in this case, how many cells are conditions? It's just simply taking those numbers, oops, can't type today, by 2 equals 4, okay, and then we have 4 cells, right? How many interactions are possible? Okay, well, interactions you can think of as combinations. of these two factors. So the only combinations we have really are A times B, right? If we call the first one A, if we call the second factor B, we have A times B, and there's no other combinations we can have. So the answer in this case is 1. There's only one possible combinations of those things we can make, right? So there we go. The last one, which is usually what people see as the trickiest one, is given that there's 10 observations per cell, how many participants were there? To answer this question, you need to know the type of design it is, which we know this is a between subjects factorial, and of course the number of observations. So if I go back up here, and here's a 2 by 2, and if I have 10 people here, 10 people here, or 10 observations in each one of these cells, so there's 40 observations total, right? Meaning if it's a between subjects design, these are all different people, right? Okay, so in this case, it's just taking that 10, multiplying by the number of cells you have, which is 4, right? And we'll get 40, okay? And that would be 40 participants in this case. And that is how you answer that question. Now, let's move on to another type of design, all right? So in a within subjects factorial, right? Now keep in mind the difference here is with the within subjects factor, all the people in each one of these cells, right, is going to be the same. So if I have subject 1, 2, 3, 4, 5, this is subject 1, 2, 3, 4, 5, subject 1, 2, 3, 4, 5, and subject 1, 2, 3, 4, 5. They're the same people. It's just they participate in every level or every condition of this study if it's a completely within subjects factorial. So the question becomes, how many factors are there? Well, you still have A and B, right? So that is 2 factors again. How many main effects are possible? Nothing's changed. That's 2 because you have a main effect for each factor. How many cells and conditions are there? Well, once again, that hasn't changed. So 2 times 2, right? See if I can do any better typing. Is 4 cells. And how many interactions are possible? Well, that also hasn't changed. A by B, right? So there's just 1. Given that there's 10 observations per cell, how many participants were there? This is the question that would change, right? Because this is a within subjects factorial, right? So they're all the same participants. Okay, so if each one of these factors is a within subjects factor, this is kind of what I want you to do, right? Since they're the same, what you're going to do is change any time you see these things, okay? Change the number of levels to 1 for this question, okay? If it's a within subjects factors. And with that, what that will tell you is how many cells do you have with different participants in them. And of course, all you really have is one group of participants in this whole study. So 1 times 1 gives you 1. And now, if there's 10 observations per cell with different folks in it, right? All we're really doing is taking that 1 cell times the 10 observation, and we'll have 10 participants. Okay. The only trick of doing that is just going, hey, if it's a within subjects factor, I'm going to change that score, whatever it is, to a 1. All right. Now, using the same stuff, we're going to go down to a mixed factorial. Mixed factorial is where you have 1 between subjects factor and 1 within. And in this case, I have to tell you which one is within or mixed or between. So the mixed factorial here, you have a second factor, which is the within subjects factor. So it's this second one here. Just like before, how many factors? A and B. So you got 2. How many main effects? That's the same. Not 1. 2. And how many cells or conditions there are, right? 2 times 2 gives you the 4. And how many interactions are possible? Well, there's only one combination of those 2 things you can make, so that is still 1. Okay, given that there's 10 observations per cell, how many participants were there? This is where I kind of make the point, if you didn't quite get what I was saying about changing those 2s to 1s and so on. So we go back up to the design. We go, okay, are there any within subjects factor? And it says the second factor is a within subjects factor. So I'm going to change that 2 and make it a 1. And now what we have is there's 2 cells, right? 2 times 1, 2 cells that would have different participants in them. So I'm going to take that 2, multiply by 10, and I get 20 participants. Okay. So what that means, since there's 40 total observations, right? There's 20 participants, and they participated twice, okay, in 2 different conditions of this study. Mainly the 2 different conditions would be whatever we called this second factor. Okay, hope you're with me. Now we're going to move to a 3-factor study. Okay, so in this one, we have a 3 by 2 by 4 mixed factorial, with the third factor being a within subjects factor. Right? Looks a little complicated, but it's the same kind of thing. So how many factors are there? Well, in this case, you have factor A with 3 levels, right? You have factor B that has 2 levels, and you have factor C with 4 levels, right? And so how many factors? Well, there's 3. Oops. 3. There we go. How many main effects are possible? The rule is still the same. You have a main effect for every factor. Okay, so that is also 3 main effects are possible. How many cells or conditions are there? That's the one we multiply. So 3 times 2 times 4, right? 6 times 4 gives me 24. So you have 24 cells. How many interactions are possible? Now we have A, B, and C. We can make some combinations of this, right? So these are the combinations we can make. We can make A by B. We can make A times C. We can make B times C, right? And we can make A by B times C. And so when we count those up, right, you have 4. So 4 interactions. Interactions, right, are possible. Now, just look at these interactions, right? The A by B, I got these little spaces, let me take them off. So A by B means that's a 2-way interaction, right? There's just 2 factors. So this is a 2-way A by C, B by C is a 2-way. This A by B by C, of course, would be called a 3-way interaction. Okay, so you have 3 2-ways and 1 3-way interactions for that one. Given that there's 10 observations per cell, how many participants were there? Okay, now we go back and go, okay, do I have a within subjects factor? Yes, we did. The third factor is a within subjects factor, so I'm going to take that one and I'm going to turn it into a 1. And now we have 3 times 2 times 1, which is 6, right? So we have 6 cells with different participants in them, and all I have to do is 6 times 10 equals 60. Okay, 60 participants, and there you go. One thing to note on here, so this question of how many interactions is 4. It doesn't matter if this was 300 by 200 by 100, right? The number of interactions would be the same. Okay, number of cells would change, right? But the number of interactions would remain the same. So for any 3-factor study, there are 4 interactions possible and 3 main effects. Okay, let's move down to another one. And this will be the last one for you. And I'm not going to go beyond 4 factors. You probably will have a 4-factor on your exam. Okay, I have you kind of break down this way, but in a 4 by 3 by 2 by 3 mixed factorial with the first and last factors being within subjects factors, right? How many factors are there? Okay, in this case you can go, okay, factor A has 4, factor B has 3, factor C has 2, factor D has 3 levels. So you have, right, A, B, C, and D equals 4 factors, right? And of course, if you have 4 factors, main effects, there's one main effect for every factor. Okay, so 4 of those are possible. How many cells are conditions? This is the one you multiply all the numbers. So 4 times 3 is 12. 12 times 2, 24. And 24 times 3, what is that? 72, okay, I believe. I'm just going to write that out real quick. 4 times 3 times 2 times 3, right? And I just want to make sure here. Let's see. 4 times 3 is 12. 12 times 3, 36. 72. Yeah, that's right. So 72 cells in the design. Okay. How many interactions are possible? Well, if it was 3 factors, I could tell you 4 right away. Since it's 4 factors, I could tell you 11 right away just because I know it. But let's do the long way just so you make sure. Okay, so we got A times B times C times D in this case. So A times B, A times C, A times D, right? B times C, B times D. What else we got? C times D. And so we have 6 two-way interactions. I think that's all of them. And then we have A times B times C. We have A times B times D. We have A times C times D. We have B times C times D, and we have A times B times, oops, I'm all over the place here, sorry. Last one's the 4-way is what I'm trying to do. C times D. Okay, so if we count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 interactions are possible. Okay, in that type of design. Once again, if the numbers change, they could be a 2 by 2 by 2 by 2, or a 300 by 200 by 400 by 659. Doesn't matter. It will always be 11 interactions that are possible. Okay, so whether you want to kind of do it the long way or just memorize a couple numbers, and really all you have to remember is, well, if it's a 2-way, there's just 1. If it's a 3-way, then there's 4. If there's 4-way, right, there's 4 factors, that is, then it's 11, and there's those numbers. So the last one, given that there's 10 observations per cell, how many participants were there? So if you followed me through this whole video, right, we go, okay, what are the factors that are within? It says the first and last. So we're going to take that one, make it a 1. We're going to take the last one, make it a 1. So now we have essentially 1 times 3 times 2 by 1, which is 6, right, cells that have different participants in them. And so if you do it correctly, you have 6 times 10 observations, and there you have your 60, okay, participants in this study. And that hopefully will give you enough to go on to be able to complete the assignment for this unit 12, which is, I know it's chapter 11 stuff, but this is more chapter 12 stuff that I have you doing, but I want to make sure that you're up to speed when it's you're talking about your project. So if you have any questions on it, just let me know.